Hi, so this is our first of our video homework for this week. We are, if you will, open your math note so it looks just like mine to the next available page. We're going to date it, so please write today's date down. And then we're going to, today's lesson is what's the size of my number? So when we do these videos, your notes should look just like mine. When I copy something down, you copy something down. If I'm going too fast, simply pause the video. There's a way, if you can figure out how to do this, if not, we could show you sometime in class. There's a way to speed up a video and there's a way to slow down a video. So if you want it to go slower, you can adjust the setting of how fast the video moves. But you can always pause and rewind. That's the great thing about these videos. So at times I will ask you to pause the video. Times I'll ask you to do your own thinking and write it down. In order to be most successful, you need to follow those directions. All right, so the first one, I would like us to compare two numbers. So 4,000, and we're going to compare that number to 40,000. So take a minute and think about how these two numbers compare. So compare is how they're alike and how they're different. Okay, so if you said that maybe the first is smaller, okay, the second is larger, there is a 4 in both of them. Both of them have zeros. So these are kind of some obvious things that we can see right off the bat. Let's compare the actual size of what one is versus the other. So I have 4,000 as my number. So 4,000, what's the difference between 4,000 and to get to 40,000? What do I have to do with the 4? I know the 4 simply has to move over one place value. So what happens when you move over one place value? So let's start that sentence and let's investigate how I could finish that sentence. When I move a digit one place value, how could I finish that? What are all the ways that I could finish it? When I move one place value, what happens? How many 4,000s would it take for me to get to 40,000? So I could count up by that. 40,000, another 4,000, 8,000. Let me keep track here. 4,000, 8,000, 8,000 plus another 4,000 is 12,000. 12,000 plus another 4,000, 16,000. 16,000 plus another 4, so 16 plus 4, 20,000. 24,000, 28,000, 32,000, 36,000, 40,000. So I'm counting by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. But instead of counting by 4s, I'm really counting by 4,000. So every time I list a number, I should put the word thousand at the end. So how many 4,000s did I have to add together to get over to 40,000? How many of them were there? 5, 6, 7, 8, 9, 10. So how many 4,000s did it take to get over to 40,000? So it is 10 times. It took 10 times for me to get to 40,000. So to get from 4,000 to 40,000, I needed 10 times of 4,000. So I'm going to give you another example and we're going to finish this sentence. So how do these numbers compare? 30, 300, 3, and 0.3. What would I do with those numbers? How could I compare them? So we could do just like we discussed. There's 3's in all the numbers. There's 0's in most of them. This one does not particularly have a 0, but I could add some by putting decimals and zeros. So they all have a 3, but the 3 is in different place values. This isn't really working for me so much that they're in a mixed up order. So I'm going to make myself a place value chart, and I'm going to put a decimal in there. So I have 3. 3 would go here. I have 3/10. I'm going to put this one above it. Okay, I have 30. So I'm just putting them in order. 3/10, 3/10, 3 ones, 30, and now I have my 300. So basically, let me add my decimals in so it looks logical. I'm going to add some zeros in here so it kind of looks symmetrical and it looks the same. So I want to look at those 3's and I'm going to compare them. So I could look at patterns every time the 3 is shifting to the left. So if I started, so I just cut out a little 3 that I could actually move here. This would be 3/10, 3 dimes. I'm going to talk money. I'm going to move over to $3, 3 tens, 3 $10 bills, $30, or $300. So how do they compare? Or I could go back this way. I could go backwards. $300, $30, $3, 3 dimes, 3/10, 300s, 3/10s, no th, 3 ones, or 3/10. So what is happening to every one? How many sets of 3 dimes would I need to make up $30? I could still count. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. 3 compares to kind of what looks like 30. 3 dimes, 30 dimes equals $3. Again, I needed 10 groups of those. So if I have $3, how many $3 is it going to take for me to get to $30? $3, $6, $9, $12, 15, 18, 21, 24, 27, 30. $3, I need 10. So every time I move in this direction, what's happening? How many times bigger is this one? How many times bigger is this one? How many times bigger is this one? So I'm gonna write this. When I moved the 3 to here, I needed 10 times them. Every time I moved the 3 from here and I went there, I need 10 times. Every time I went from here to there, I needed times 10. We talked about this before with the patterns of 0. So every time I move over, I'm multiplying by 10. So when I move a digit one place value, it gets 10 times larger or smaller. Well, we didn't talk about it getting smaller, but I have my 3 over here and I move it one place value, it's getting 10 times smaller because I could break 300 up into 10 groups. Remember these 10 groups we counted up? I could divide them into 10 parts. Could divide them into 10 parts. I could divide them into 10 parts. So if I wanted to look at this in a more simplified way, I could look at my rod that I have here, and if I wanted to see how many, you could hear me clinking some base 10 blocks over here. Let me grab them real quick. So I want to see how many fit inside of here. So I'm not talking about 3's, I'm talking about, or I'm not talking about 4's, I'm talking about 1 this time. I have 1 rod, and I'm going to see how many units fit inside of it. I know we investigated this in class already, so I can predict what's going to happen. So there's 6, 7, 8, 9, 10. So there's 10 that fit inside of this. So I need 1 times 10 to move over. One of these times 10 will get me here. Need one of these times 10. I need 10 of those to fit into here. One of these times 10 to get bigger. So if I want to go the other way, one of these divided up into 10 parts gives me this one. This flat, 100, there's 100 of these here, divided into 10 parts gives me one of these. One of these divided by 10 gives me this one. So every time I move from a place value, I am either getting 10 times larger or I didn't finish my thought here, or smaller. This is a very important concept that we're getting right here, so I'm going to kind of make this stand out. So as I'm flipping through my notes and I need to go back and refer to this, I have this here. Let's see if I can find a highlighter over here. I don't seem to have one right here. So when I move a digit, one place value gets 10 times larger or smaller. So another fact that I know that I do not forget, did I ever move this decimal? When our parents and myself, when I learned in school, we didn't move digits, we moved decimals, and it was a shortcut and it didn't help us understand math very well. So I'm going to make a note. Decimals never move. Decimals are kind of like our chairs. Our chairs in the classroom, even though we move them around sometimes, our chairs just hold the spot for us to sit. Our chairs are not important. It's the people or the numbers that are important. The chairs are just serving as a spot for us to sit. A decimal just serves as a spot for us to sit so we remember how to value numbers. Decimals do not move from one place to another. Your parents would probably tell you just shift the decimal around. Decimals don't have the power to move. Decimals don't move. Digits do. So we're not talking about moving the decimal places. We're talking about moving the numbers. So we're really shifting the numbers to get larger and to get smaller. So if you need to rewatch this video, or if you need to rewind something because you did not get all of the notes, please do that. Thank you.